Welcome back to another online lesson. Today we are going to talk about linear equations, linear relations, and how we write them in the different forms that we use, how we can find slope and intercept, and things like that. So we're going to break this down. I'm actually going to do two separate lessons. First, working with linear relations, and then the next one is going to be looking at x and y intercepts. So that's the next thing that we will talk about. So let's go ahead and get started. Linear relations. This picture that we have right here shows a linear relationship because all of the points are in a line, and that's all that it means when we have a linear relation, is that our points together form a straight line. And linear relations can be represented by an equation, a linear equation, which would be something like x plus y equals 8. So that is a linear equation, and there's a couple different ways that we can write linear equations, and the first one is called standard form. That one that's given x plus y equals 8 is standard form. That means that it's the format of a times x plus b times y equals c. Sometimes a and b are 1, like they are in x plus y equals 8. Sometimes they're other numbers, but we do have some stipulations. If it's in correct standard form, a, b, and c have to be integers, so they can't be fractions or decimals. A has to be greater than 1, so it can't be a negative number. And the greatest common factor of those three values, a, b, and c, is 1, which means they can't have any common factors. They can't all be divisible by the same number. And you'll see some examples of what it looks like when they are not, and how we fix that. So let's take a look at our first three problems that we're going to do together, and then you'll have a few to do on your own. We're going to rewrite each equation that's given and put them in standard form. So the first thing we want is we want to make sure that we're meeting those requirements. Are a, b, and c integers where a is greater than or equal to 1? And -5, +6, and -12 are all integers, but a, the coefficient of x, in this situation is not greater than 1, so we need it to be greater than 1. So if we have -5 and we want to make that a number greater than 1, what we'd have to do is multiply by something to make it positive. And so the easiest, or divide, multiply or divide by a number that will turn a positive into a negative, or a negative into a positive. So we don't want to multiply them all by a number bigger than 1, because then they'd have a greatest common factor that we would have to get rid of. So we just, whenever our a value, as it's written, is a negative, we just multiply or divide the entire equation by -1. So that's what we're going to do here. Since a is not greater than 1, we're going to divide every single term in that expression by -1. So we're going to take -5x divided by -1, +6y divided by -1, and -12 divided by -1, which just changes the sign of all of those terms. So when we change the sign of all of those terms, we get 5x minus 6y equals 12. And now it's in standard form. The greatest common factor of 5, 6, and 12 is 1, and all of those values are now are integers with a greater than or equal to 1, so we're in good shape there. All right, let's look at our next one that we're going to do together, which is number 3. So on number 3, we have 9x plus 6y minus 24 equals 0. So this one, we have a couple things that are not standard form about this, things that we need to fix to put it in standard form. And the first thing is, notice we have this minus 24 on this side of the equation, and we don't want a constant on that side of the equation. We want our constant on the other side of the equation. So we want to take that 24 and move it to the other side. And I always say, if you change sides, if you change which side a term is on in the equation, it changes its sign. So you'll hear me say that a lot. Change sides, change signs. So we're going to move our 24 to the other side of the equation, and we do that by adding it to both sides, which makes it positive when we move it to the other side. So that gives us 9x plus 6y equals 24. And now we're super close. It's kind of in this format, but the problem is 9, 6, and 24 are not, the greatest common factor of those is not 1. They're all 3 divisible by a common number. Specifically, they're all 3 divisible by 3. So we have to divide all of them by 3 to get them so that they have a greatest common factor of 1. So we divide by that greatest common factor of 3, and 9x divided by 3 is 3x, 6y divided by 3 is 2y, 24 divided by 3 is 8. So we get 3x plus 2y equals 8. And now it's in standard form. So you've got to look for all of those things. We want it to match this format. We want the greatest common factor of our 3 values to be 1, and we want A to be greater than or equal to 1. All of those things have to be true. All right, so the next one we're going to look at is a little bit different. Number 5, we have 3/4 x minus 1/3 y equals 1. So we have the correct format. We have something times x plus something times y equals something. But A, B, and C aren't integers, okay? A is not greater than or equal to 1. We need to change them into integers, and when you're dealing with fractions and you want to get rid of fractions, we want to look for the greatest common denominator, or the greatest common, or the least common multiple, sorry. Least common denominator, or the least common multiple of our denominators. So the least common multiple of 4 and 3, the smallest number they both go into, is 12. And what we do is we're going to take that whole equation and we're going to multiply by 12. When we do that, we're able to eliminate those fractions. So we distribute it all the way through. 12 times 3/4 is 9. 12 times 1/3 is 4, and 12 times 1 is 12. So we get 9x minus 4y equals 12. So now they're all integers. A is greater than or equal to 1. Greatest common factor of 9, 4, and 12 is 1. They're not all, there's nothing else that goes into all 3 of those. Okay? All right, so I'm gonna have you pause the video here and give it a try. Do numbers 2, 4, and 6. And when you're finished, come back and we will take a look at those solutions. All right, so hopefully you've finished those 3. Let's take a look at number 2. Y equals 2x minus 9. I'm gonna go through this really quickly, show you some steps. First thing we need to do is we need to move the x part of that equation to the other side. So we subtract 2x from both sides. We get negative 2x plus y equals 9. We're close, but a has to be greater than or equal to 1. So we multiply everything by negative 1 or divide. Either way works, which changes the sign of all the terms. So it becomes positive 2x minus y equals positive 9. So notice all 3 of those changed signs. All right, on number 4, your solution that you should have come to is x plus y equals 1. And on number 6, we're looking for x minus 6y equals negative 12. Hopefully you got those answers. If you didn't, be sure to let me know if you have any questions. Go back and look them over again, see if you can figure out what you did wrong or what you missed. All right, let's move on. The next section, this should be very familiar. We're going to look at slope-intercept form. So up here, we talked about standard form. Standard form is ax plus by equals c. Slope-intercept form is when we write an equation in a different format, one that's probably very familiar to you, y equals mx plus b. Y equals mx plus b could also be f of x equals mx plus b if we're using function notation. So those are the same. M, of course, is our slope, and b is our y-intercept, okay? Now, when we're in slope-intercept form, this gives us a nice clear picture of what's happening with our graph of our linear equation. And Slope tells us how slanted the line is and whether it's slanted up or slanted down. If it's just a slight slant or if it's really sloped. There's actually 4 different rates of change, 4 types of slope that we might see when we look at linear equations. Remember, slope is rise over run. Our 4 types of slopes that we will see are, first of all, a positive slope. Positive slope, if m is positive, we're going to have a line that goes upward from left to right. Okay, it's going uphill. If we have a negative slope, we're going to have a line that slants down. Okay, so it's going downhill or decreasing from left to right. And then the other 2, we don't see very often, but they're very, you need to know these as well. We have a 0 slope. So if I think about something that has 0 slope, to me that means it's flat. Okay, so it would be horizontal. Okay, horizontal line has a 0 slope. And then if we think about the last one, if horizontal is 0 slope, then undefined is the last one. And when you think about this, this really makes sense, because if it's straight up and down, which is what an undefined slope is, it's not really slanted, but it's not flat. So we couldn't say it has no slope. We would say it's not a 0 slope, because that would imply it's flat. So it's undefined. And the reason why it ends up being undefined is because when we calculate slope, the run, which is the distance that you move from left and right as you go from point to point, ends up being 0. And we know division by 0 is undefined. So for instance, if I take a point here and a point here, and I look at the rise, it goes up, I don't know, whatever, however many units that is, we'll say 4. But left and right, it doesn't go any distance at all. So 4 over 0 is not defined. So that would be a vertical line. So undefined slope means that it is vertical. All right, so let's take a look at some problems with slope-intercept form. We are going to do numbers 7 and 9 together. We're going to find the slope, find the intercept, and graph the line. Okay, we want it to be in slope-intercept form to do that. So this first one, y equals 2/5 x plus 7, that one's done for us. It is already in slope-intercept form. So all we have to do is identify our slope and identify our intercept. So we're just matching things up here. So our slope is the part in front of x, so that's the 2/5. And our intercept is the part that's added or subtracted on at the end, so that's plus 7. So 7 is our intercept. Now, when you go to graph a linear equation, you always start with your y-intercept, because that tells you where you're at on the coordinate plane. It's on the y-axis at 7. So we put a dot at 7 on the y-axis. And then from there, we're going to count out our rise over our run. Now, we run into a little bit of an issue on this one. I'm supposed to go up 2 and then to the right 5. I can't go up 2 and to the right 5 because my graph only has one more spot above. So I can't go up 2 and over 5. The alternative is to do down 2 and back 5. So if we think about if I go down 2 and back 5, that is still 2/5 because they're both negative. So negative divided by negative is a positive. So if I go down 2 and back 5, it puts me right there for my next point. You could do that as many times as you needed to, but once you have 2, you can connect the dots to draw your graph. Okay, so this should definitely be a review. You should be able to fly through these pretty quickly. On number 9, we do not have an equation that's already in slope-intercept form. We need to put it in slope-intercept form, which means we need to isolate our y variable. So we're going to move that x to the other side to get the y by itself. Okay, so we move x, which gives us 3y equals negative x, because we changed sides, so it changes signs, minus 15. But we want y completely by itself. We don't want that 3 in front of it, no coefficient. So we divide everything by 3. And I want you to think about this x having a negative 1 in front of it. Okay, so it becomes y minus 1/3 x, 1 divided by 3 is 1/3, minus 5. 15 divided by 3 is 5. Now, we have our slope is negative 1/3. Our y-intercept is -5. We plot the -5 on the y-axis. And then again, you have two options. You can go down 1 and over 3. You could go up 1 and backwards 3. That would be plotting a slope like this, which is also fine. But here's your next point. Connect the dots. Okay? All right. Pause the video, take a couple minutes, do numbers 8 and 10, and then come back and check your work and see how you did. Okay, let's take a look at number 8. Let's see how you did on that one. Negative f of x equals negative x plus 2. Again, it's already in slope-intercept form. We have no reason to change this. There's our intercept is 2. Our slope is -1, down 1 over 1. I did it twice, down 1 over 1, down 1 over 1, just to spread my points out and make it easier to get the line correct. Draw the line. Number 10, we have an equation not already in slope-intercept form. So you have to put it in correct form, which is y equals negative 4x plus 1. So you move the 4 and the 1 to the other side. And then plot your intercept, find your next point using your slope, and connect the dots. So far, so good. Hopefully you're feeling comfortable with all of this. Our last thing we're going to look at now is those vertical and horizontal lines that we talked about on the 4 different kinds of slope. So on this first picture, we have a vertical line. Vertical lines are written like this one would be x equals -3. Okay, so all along this line, the x coordinate is -3. No matter where you're at on that line, the y's can be anything. So always look for what's consistent all along that line. And consistently, x is -3. Vice versa, in the horizontal lines, when we have a horizontal line, it's y equals, and then whatever that is crossing, whatever point it is crossing the y-axis. So y equals 1 is the equation of this line. Y is always -1. So every single point I could find on that line would have a y coordinate of 1. So y is always 1. All right. So that's vertical and horizontal lines. Now, one more thing. When we think about lines, if a line is telling us about the slope, or if an equation is telling us, if the slope is telling us how slanted a line is, then if I have 2 lines, and one has a slope like this, and the other has a slope that's the same, what is true about those lines? Well, they are going to stay the same distance apart all the time because they're the exact same slope, which means they are parallel. So the slopes of parallel lines are going to be equal. Now, if we have 2 lines that are perpendicular, notice one is negative and one is positive because one is going uphill and one is going downhill. And they're going to have slope values that are not only opposites of each other, but they are going to be reciprocals. So when you have perpendicular lines, these are going to be slopes that are negative or opposite reciprocals. So like 2/3 and -3/2, 1/4 and -4. Those are reciprocals. 5/6, -6/5. Those are opposite reciprocals, okay? So what we have on this last section is we need to determine whether the lines that we are given equations for are parallel, perpendicular, or neither. So the first one is 10x plus 5y equals 5, and -x plus 2y, equals 2y plus 16. On the first equation, we're going to rewrite it in slope-intercept form. So we're going to move the 10x to the other side, which gives us 5y equals -10x plus 5. Divide everything by 5 to get the y completely by itself. And when we divide everything by 5, you don't get that. That was my mistake. I did that wrong. It's y equals negative 2x plus 1. But here's the deal. That mistake that I made right here doesn't really matter because we're not even going to look at the y-intercept. We're looking only at the slope, okay? So the slope is 2. And then the other line, we have negative x equals 2y plus 16. I need to flip-flop my x's and my y's so that I have y equals. So I'm going to put negative 2y equals x plus 16. They both changed sides, so they both change signs. Divide everything by negative 2, and we get negative 1/2 x minus 8, and m equals negative 1/2. So are they opposites of each other? Is one negative and one positive? They're both negative. So they're reciprocals, but they're not opposite reciprocals. One has to be positive in order for them to be perpendicular. They're definitely not equal, but they're not negative reciprocals. So that means these are neither parallel nor are they perpendicular. They're just, one is like this and one is like this. Okay, so they're not perpendicular, but they're not parallel either. All right. The next one we're going to do together is number 15. We're going to get the y by itself. So I move the 8y to the other side, or sorry, the 8x to the other side, which makes it positive 8x. Divide both sides by 8, and then we get y equals x. So even though this doesn't look like it's in slope-intercept form, we could put a 1 plus 0 there, which would make it a slope of 1 and a y-intercept of 0. On x minus y equals 4, again, isolate the y, move that x to the other side, and we get negative y, because that negative sticks with the y, equals negative 4x. He changed sides, so we change his signs, plus 4. All right, and then we want that y to be positive, so we need to change the sign of every single thing. So this negative becomes positive, that negative becomes positive, that positive becomes negative. Our slope is 1. So slope of 1, these are equal, which means our lines are parallel. Okay, last 2 problems for you to try on your own for this video. Pause it and do numbers 14 and 16. Come back and we'll check out the answers. Okay, let's see how you did on number 14. Your first equation, you should have got a slope of 4/3. The second one was also a slope of 4/3, which means they are parallel. And this last one was a little bit tricky. So if you got stuck on that, just flip the page over and look, or just look up here at this number 11 and 12. And these are a vertical line and a horizontal line. So I know they're not opposite reciprocals, but really they are, because one is a 0 slope and one is undefined. So, I mean, I guess undefined is not the reciprocal of 0, but you can't put 0 in the denominator. So vertical and horizontal means they are perpendicular lines. So, all right, that's it for this video. Be sure that you watch the next one over x and y intercepts, which is also part of today's lesson.